Hello, I am Mr. Ford, and today we're going to be looking at lattice multiplication. So lattice multiplication is just another method that you can use to multiply. It involves using a grid, and I'll show you how that works. The grid is the only new term that we're going to be introducing today. So all the other terms still apply. Your factors, your multiplicand and your multiplier, your product, all of those terms stay the same. The grid is basically the way that we are going to organize answering our problem. And it breaks it down a little bit further than traditional multiplication so that you can clearly see all the different parts that you're multiplying together. So let's begin. We're going to start with a double by single digit problem. So we're going to start with 68 multiplied by 7. And you can see immediately that unlike traditional vertical multiplication, where we would write this as 68 multiplied by 7, and we have to line up all of the place values, in lattice multiplication, you're creating a grid, and how wide your grid is based on how many digits or place values your multiplicand has, and how tall your grid is dependent on how many digits or how many place values your multiplier has. So once you've created the frame of your grid, this kind of box, you're going to just draw a horizontal line. And because we're on grid paper here, this makes this really easy. We're going to go from one corner to another and keep going one line extra down. We're going to do the same thing here. We're going to finish off the center of our grid like that. So inside of our grid, we're left with 4 boxes. And these boxes, they represent your 1s and 10s for the answer of each individual part. So let's do that. Just like traditional vertical multiplication, we're going to be starting on the right. We're going to take our 7 and multiply it by 8. We know that 7 multiplied by 8 is, oh my goodness, 56, and so we're going to be putting our 5 in the uppermost portion of this section of the grid to represent the 10s, and we're going to be putting our 6 in the 1s, whereas in traditional multiplication we would leave our 6 down here in the 1s, and we would regroup our 5 above to the next side. Next, we can multiply 7 by 6. So 7 multiplied by 6, we know is 42. So same thing, we're going to put the 2 in the lower column to represent the 1s, and we're going to put the 4 in the higher column. Now, we have our individual answers for 7 multiplied by 8 and 7 multiplied by 6. We need to now add these together. If we had done that over here, we would have come up with 42. You would add 5. 47. Let's see if it comes out the same on this side. This is where these diagonal lines of your grid come into play. We are going to shift all of our numbers diagonally in line to this lower column. So we're going to drop our 6 down. There's nothing underneath it. We're not adding anything together. It's just 6. Our 5 and our 2, they're kind of in this same diagonal column. So we're going to add those 2 together and come up with 7. And 4, again, it's on its own. There's nothing over here. So we're going to move that down. And what we end up with is the same product as if we had done this with what many would consider the traditional vertical multiplication method. So let's try a couple other problems. All right, so we have 4 more problems here. The first 2 are double by single digit or tens by ones place value multiplication problems. The third and fourth are a little bit different, so we'll talk about those when we get to them. So starting up here, again, we're starting on the right. We multiply 4 by 3, we get 12. 2 goes in our ones place in this part of the grid, 1 goes in the tens. 4 multiplied by 7, we get 28. I'm going to put 8 in the ones, 2 in the tens. Now we're going to slide them all down, add them together with any other numbers in the same diagonal column, and get our product. 2, there's nothing else there. I'm going to put a 2. 1 and 8, we're going to add them together, we get 9. 2, again, it's on its own, we end up with 2. And so therefore we get a product of 292. Moving on to the next problem. 8 multiplied by 9 is 72. 8 multiplied by 3 is 24. 2, add to nothing, sliding it down on its own. 7 and 4 creates 11, but we can't fit 11 here because this is a single place value. So just like in addition, we need to regroup. So we're going to keep the 1 from 11 here. We're going to put the other one up there. 2 add 1 equals 3. So we get a product 312. So I went a little fast there, but this is the general rule. If you go just like in addition, if you're working in a place value column and you get larger than 9, 10 or 11 or 12 or anything like that, then you need to regroup the 10 to the next column over and add it to whichever numbers are there. So we're going to be moving on to a triple digit by single digit problem, and you might be thinking, uh-oh, this number is much larger. I can't make groups of that. Well, don't worry. Once you understand the lattice process, just like any other multiplication process, you can increase the place value, you can increase the size of the number, and the process itself doesn't change. It just becomes a couple extra steps that are the repetitions of the same steps you've already done. So let's take a look. You have 9 and 134. So 134 multiplied by 9. Well, same thing as we did in our other problems. We're going to start off with 9 multiplied by 4. I know that that is 36. 9 multiplied by 3 is 27. 9 multiplied by 1 is 9. I'm going to put a 0 there just to hold my place so I can be sure that I haven't missed a step. Right? So all I did was I just multiplied 9 by one other place value. We add them together just as we did with the other problems. 6 on its own. 7 and 3, so we're regrouping again. Leave the 0. Regroup that 1. 1 and 2 is 3. 3 and 9 is 12. Regroup that 1 again. 1 and 0 is just 1. And we're left with a product of 1,206, or 1,206. So that's triple digit by single digit. And you can increase this. This could be 4 digit by single digit. It could be 5 digit by single digit. The process stays the same. It's just increasing the number of steps. Now let's move on to something that has a couple additional steps, and that's 2 digit by 2 digit lattice multiplication. Now you might be looking at this going, okay, well, this factor right here, is quite easy to read. I can read it as 54 from left to right, but this one here, am I reading it from top to bottom? Is this 3? Or am I reading it from the top down? Is this 30? And a typical rule when you're thinking of these problems, if I wrote this up here, when we are moving into lattice, the highest place value of your multiplier will always be on top. So we're reading this from top to bottom. 54 multiplied by 30. Just like a traditional multiplication problem, we're going to start with the smallest place value. So 0 multiplied by 4. Well, anything multiplied by 0 is 0. Same thing with 5. And then we come up here to our next smallest place value, which in this case is our highest place value, which is the tens. So we have 3 multiplied by 4. It's 12. 3 multiplied by 5 is 15. And now we're going to add them together diagonally, as we have with the other problems. And as you start going up, because you'll start to notice the larger your numbers get, they start moving upwards. And that's fine. We're still reading them from top down. So we end up with a product of 1,620, or 1,620. We're going to be doing another video on double digit by double digit multiplication. We're going to look at some more lattice problems as well as some traditional multiplication problems, some problems where we break some numbers apart. So, if you are interested in learning how to use lattice, you can try these problems. We have problems on our blog. If you are struggling with double digit by double digit multiplication, you should also look at the next video.